we are interested in either the step or the natural response. And in both cases, the solution will be of the following nature. So if we are interested in the if we have a natural response, then the final value will be 0. If we have step response, then the final value will not be 0. Again, T naught dagger is equal to T naught if we're talking about current on inductor or voltage on capacitor, and T naught dagger equals to T naught plus otherwise. Okay, this is clear, Shabab? Ahmed, question?
دكتور عادي ان تكون الاي initial تكون natural response تكون 0 يعني.
The natural response I initial is not 0.
Same. Okay.
Okay. Yeah, it could be. No, the natural response the natural response should be decaying. Okay, leave this question to office hours. I want to solve this problem. طيب. Okay, we're given an RC circuit, and this we're told that the capacitor was initially charged to 1 volt. After 1 second from closing the switch was originally open. After 1 second from closing the switch, the voltage across the capacitor becomes 2 volts. So what happens is that we know the voltage across the capacitor must have the following form. Okay. So what we are asked, we don't know the value of Vs. We are asked to find the value of Vs, the value of the voltage source. But we're given that the voltage across the capacitor at t equals to 1 second. 1 second is 2 volts. So let's try to fill in the information here and see what we can. What term is missing in this formula? So the initial value is given to us. The capacitor was initially charged to 1 volt. So that's the initial value. The final value is going to be equal to Vs. So the final value of the voltage across the capacitor will be the same as the voltage across the source. The time constant tau is R multiplied by C, where we know R, we know C, so it's going to be 1 multiplied by 1, and it's going to be 1 second. So at t equals to 1 second, we substitute Vc of 1 second. We are given in the question that it's 2, and this one should be equal to V final, which is Vs, plus V initial, which is 1 minus V final, Vs, e to the power t divided by tau. Tau is 1, so e to the power -1. Okay, so now we can actually solve for Vs. So the solution is Vs is 2 minus e to the power -1 divided by 1 minus e to the power -1. And this is the correct solution. Any questions, Ch7? Okay, this is straightforward application. Let's see if we can take it a step further here. Let's try to solve this problem. And in this problem, we are asked about the time constant. So if you are asked about the time constant, you need to know two things. You need to know the equivalent capacitance or equivalent inductance and equivalent resistance seen by the capacitor. So for t less than 0, or I'm sorry, for t greater than 0, we have the following circuit. So what we need to do is we need to find the Thevenin resistance seen by the capacitor. Let us find R Thevenin seen by the capacitor. So if we want to find the Thevenin resistance, first of all, we need to disconnect the capacitor, because we are looking into, we're trying to find the Thevenin resistance seen by the capacitor term. So how to find the Thevenin resistance here? There are actually two ways. The first one is we need to find the Thevenin voltage. Then we need to find the short circuit current. And since here we're not asked about, I mean, we don't need the Thevenin voltage. All what we need to do is to find the Thevenin resistance, because remember here, tau is R Thevenin or R equivalent multiplied by C. So I know C is given to us is 2 farad. R equivalent is the one that we are interested in. So what I'm going to do is I'm going to apply a test source. So let me apply a test current source. And try and find the voltage of this test source. Okay, so if I'm applying a test source, the first thing you need to do is to deactivate all independent sources. But dependent sources, they shouldn't be activated. They shouldn't be deactivated. So this is my current, test current, I of t. I need to find V of t. So what is V of t here? What is the voltage across the current source, the test current source? So this one is Ix. Ibrahim?
We can apply node voltage on the upper node.
We can do that.
Or we can
yeah.
apply Ohm's law directly on
Yeah.
the resistor.
Yes, exactly. So it's going to be the same as the voltage across the 1 ohm resistor, which is 1 over Ix or Ix. So let's find Ix in terms of VFT. So we know that VFT is equal to Ix. So Ix, to find Ix, we need to apply KCL. So let us Ix by applying KCL. So if we apply KCL in the upper node here, you can see that we have Ix plus 2Ix equals to I of t, or the test source. So we conclude that Ix equals to IT divided by 3. So remember, V of t is equal to Ix. Ix is equal to I of t divided by 3. So this implies that V of t equals to I of t divided by 3, and R Thevenin is going to be V of t divided by I of t, which is 1 over 3. So tau will be R multiplied by C. R is 1 over t, C is 2, so it's going to be 2 divided by 3 seconds. And this is the solution. Okay. Any question about this one? So let's try to solve this problem. And this problem is on the sequential switching, because the switch is moving between more than two states. So originally it was at position A, then it moves to position B, then it moves to position C. So it was for position A for a long time. Then at t equals to 0, the switch moves to position B and stays in position B for 1 second. Then at t equals to 1 second, the switch moves to position C and stays there indefinitely. We are asked to find the current and the voltage across the inductor. So the standard way of solving such a problem is to dissect this problem and try to divide it into three problems. So let us start, or let us study the circuit for 3 time intervals. So for t less than 0, we have 1 ohm, then we have 1 ohm. So clearly the current passing through the inductor is 0. And the voltage is also 0. Okay, this is interesting. So now let's move to the time interval from between t equals to 1 and t equals to between 0 and 1. Let's see what we have in here. So the circuit will look like the switch moves to position B. So 5 ohm is out of the picture here. So we have 4 volts. And 1 Henry here. So we are asked to find I L of t and the voltage V L of t. So here it makes more sense to find I L of t than take the derivative of the current, scale it by the inductance, and find V L of t. So in order to find I L of t, you need to find the time constant, and you need to find the final value. Salman, question?
No, just I want to participate.
Okay, so what is the final value?
We need to assume that the switch will be closed for a long time, and by Ohm's law, we need to find the current passing through the resistor, which is 4 ampere.
Okay, exactly. The time constant will be O divided by R. O is 1 Henry, R is 1. So 1 divided by 1, this is 1 second. And IL is going to be, we know that from the previous analysis. Okay, so now we have everything we need to write the expression for the current. So IL of t 4 plus and this is true for, okay. So what about VL? The answer to this one is actually we need to differentiate the current with respect to time and scaled by the inductance. So if you take the derivative, you will end up with minus okay. So now we found IL of t and VL of t in this interval. So the last part is finding IL of t and VL of t for when the switch moves to position C. So when the switch moves to position C, the circuit will look like the following. So the time constant here, we have different resistance. So it's going to be 1 divided by 5, which is 0.2 seconds. The initial value will be the value at t equals to 1. So the value of the current at t equals to 1 is 4 multiplied by 1 minus e to the power negative 1. And this is equivalent to 2.53 amperes. The final value will be 0 here. Okay, so the expression for the current is going to be, again, this response from t greater for t greater than 1 is actually a natural response, but I will not consider this this as a special case. I will not consider this one as a special case. I will assume that I have the initial value and the final value, and it will lend itself into a form that's applicable to both cases. Here, please pay attention. So now this one is centered at t equal -1. So the solution will be 2.53 ampere, and this is true for t greater than 1. The voltage across the inductor is going to be the derivative of this one with respect to time. And if you differentiate it, multiply it by the inductance, you will get minus 12.65 volt, and this one is true for t greater than 1. So any questions? Okay, so the last problem that I want to solve is actually from your textbook. The previous 3 problems were taken from, I think, an old final or something like this. But the last problem is taken from your textbook. So the switch in the circuit shown below has been open for a very long time before closing at t equals to 0. So we're asked to find V naught for t greater than 0. Okay, so we're asked to find the voltage across the inductor for t greater than 0. So what is the key element here? What is the key quantity that we need to find first? Fahim?
We need to find IL first.
Yes, we need to find the current passing through the series combination of the inductors. So once we find the current, we can differentiate this current, scale it by 45 millihenry, and this is going to give us the voltage across the first inductor. Okay, so let's try to find the current passing through the series combination of the inductors. And let me just write. So for t less than 0, the switch was open. The inductors behave like a short circuit. So you will end up with the following circuit. So what is the current passing through the inductor? Is simply by Ohm's law. Okay, this is for t less than 0. For t greater than 0, we have the following circuit. We have the series combination of the inductors. So 45 plus 15, it's going to be 60 millihenry. We have 2 kilo ohm resistance. We have 80 volts here. We have 3 kilo ohm. And we have 10 milliamperes. Okay, so what do we need to do now? So we need to actually find the time constant, and we need to find the final value. So once we find the time constant, once we find the final value, we can actually solve this. We can actually find the expression for the current, ILT. Okay, so let's apply first the source transformation. Again, you don't need the source transformation to find to solve this problem, but you can, in order to find the final value, you know that the current passing through the inductor, or the inductor will behave like a short circuit. So you can apply superposition principle as well, or you can apply any technique that you want. But let me apply source transformation for a reason that comes clear in a moment. Okay, I have 16 millihenry. Nothing has changed here. I have 2 kilo ohm in series with the voltage source, so now it becomes 2 kilo ohm in parallel with 40 milliampere source, current source. I have 3 kilo ohm, and I have 10 milliampere. 10. Okay, so if I simplify it, I will end up with the following simple circuit. So the parallel combination of 2 kilo ohm with 3 kilo ohm is 1.2 kilo ohm. And then since I have 2 current sources in parallel, so the current will add. And this is going to give me 50 milliampere. So again, I'm interested in the current here. Okay, so now I can easily find the current, the expression for the current across the inductor. And this is going to be, I need the final value. First of all, the time constant will be L divided by R. L is 1.2 kilo ohm, R is 60 millihenry. So that's going to be the time constant. And the final value of the current will be, since the inductor will behave like a short circuit, so it's going to be 50 milliampere. The initial value, remember, was 40. So 50 plus 40 minus 50, e to the power 20,000 t milliampere, or 50 minus 10 and this is true for t greater than 0. Okay, so now I found the expression for the current. Let me go back and find the value that, or the quantity that I'm interested in, which is the voltage across this inductor. By definition, the voltage across the inductor is going to be the inductance multiplied by the derivative of the current with respect to time. So V naught So if we solve for it, we'll end up with this is 2 for t greater than 0. Okay, any questions about? Salma?
Is it volt or microvolt or yes, millivolt?
No, it has to be volt because you will get 450 to the power.
Because the current is in milliampere.
Yeah, but you have 20,000 here. So and this gonna give you 90 minus 1. Okay.
Yes.
Okay, any questions, Shabab? Ziad?
Can you go back to the circuit? So when we find the current, the time constant for the current, why do we have to use L to be the combination of the inductors and not that only inductor, the 45?
When you find the time constant, because here you're getting, you have two inductors. So the whole analysis is assuming that we're interested in the whole analysis assuming that it's RL, but what we are exactly saying that it's R equivalent, L equivalent. It's not an individual one. There's some situation where you can divide the circuit into two independent circuits, but this is not one of them.
Okay, thank you.
Any other question? اوكي طيب الله يعطيكم العافية شباب. I will stop now.